This is lesson 11.3, example 3, and we'll be going over how we can recognize a normal distribution. So before we can recognize one, we have to know what one is. A normal distribution is symmetric. It's centered on the mean. And when we look at our data, we find that most of our data falls within 1 or 2 standard deviations away from that mean. And the further away you get from the mean, the less likely it is that you have data there, thus the curve decreasing closer and closer to this axis at the bottom. So when we talk about a normal distribution, we're talking about the mean specifically. When we look at situations, we have to think about average. So we've got a couple scenarios here, and the question is the following variable likely to have a normal distribution? So the first scenario they've given us is the heights of all people in a large group. And I do have histograms for each of these. I just blacked them out because I wanted you guys to think about each of the questions. So think about the heights of all the people in a large group. Potentially, when we're talking about large groups, we're talking about hundreds, thousands, millions of people. And when you think about height of people, yes, there are some people that are shorter. Yes, there are some people that are taller. But for the most part, yes, this should have a normal distribution. So when we look at the histogram, we find, there's a little bit of disparity with people who are a little bit shorter, people who are a little taller. But for the most part, we can match the data to a nice symmetric normal distribution. The second scenario they gave us is the probability of landing on each of 8 equal parts of a spinner. So if you're playing a game and you have a spinner where you spin the arrow and it lands on a number, the probability of landing on each of the 8 equal parts of a spinner, well, if they're all equal, then we have a 1 in 8 chance of landing on any one of the pieces of the spinner. So each piece being equal has an equal chance of it landing on that spot. So when we look at the frequencies, we find that there's really no distribution here, normal or skewed. It's just all over the place because we have 8 parts that could all equally be landed on. So no, that's not likely to have a normal distribution. The third scenario they gave us is the scores on an easy test. So the key here being easy, think about when you take an easy test, you expect scores to be higher. So if the test is easy, I'm expecting a higher number of scores, let's say above 80%, when we look at the histogram. And so when we look at that, if a test is easy, I don't expect a lot of people to do poorly on it, which means we end up with a skewed distribution. So this would actually be no, it's not likely to have a normal distribution. It's probably skewed left, since most of our data falls on the right and the tail end is on the left. Now, the last scenario we're going to look at is the number of children in a family. So when you think about families, on average, the American family right now has about 2.5, 3 children on average. Of course, you can't have 2.5 children. The decimal just comes from the average when you add all the households up and divide by the number of households. So when we think about that, there's a lot of families with no kids, 1 kid, 2 kids, 3 kids, but as the number of children starts to increase, there aren't as many families that would have, say, 8, 9, 10 or more children. So when we look at the data, we find that there's actually a higher number on the left, and then we tail off to the right. So no, this would not be likely to have a normal distribution. This would, in fact, be skewed to the right because of how many families have between 0 and 3 children. And from there, the number of children becomes less and less common. So recognizing a normal distribution, we have to think about the scenario. We have to think about the average for that scenario. Go ahead and take a look at the example 3, try it. There are 2 more situations for you to consider and determine whether or not they will be normally distributed. So go ahead and do that now.